The first case says we should simplify 3 all over 2 of x plus 3 root x is equal to 12. Now, for us to be able to simplify this problem, it is important to play with some mathematical manipulations that we already know. So I'm going to begin by leaving the radical part of this problem, the surd part of the problem, on the left hand side. I'm leaving it positive, while the others stay on the right hand side. This is what I mean. On the left hand side, I will be keeping 3 root x, while on the right hand side, 12 minus 3 all over 2x will be there. Yes. Now with what I have right now, I can go ahead to conduct another further operation. One thing I can choose to do first is to remove the 3 attached to x, to the root x. And how to do this is to divide both sides and each term in the equation by 3. And to do that, I will be dividing this side by 3, while I'll be dividing this whole side by 3. So to do that further, 3 on the numerator cancels out 3 on the denominator, leaving us with the root of x. While on the right hand side, what do we have? I'm going to simplify the numerator first as a fraction before bringing down the denominator. So 2 multiplies 12 to give us 24. On the numerator now we have 24 minus 3x over 2, all of them all over 3. We can see this 3 as 3 all over 1, okay? So that we can make this a simple fraction. Go a little further with simplifying this part. On the left, we still have root of x. Y on the right, what we have now will be 24 minus 3x all divided by 6. This is what we have now. Okay, since we have reached this level, we can choose to divide all the terms here by 3, a way of factorizing first before proceeding. Or we can just carry on with what we are dealing. Now, if you take a good look at this place, there is an x in the root. There's yet another x on this part. So what do we do? One thing we can do here is to take the square of both sides of this equation. What I mean is I'm going to square the root of x the same way as I'm going to square this part. So when that happens, the square of the square root of x leaves us with x is equal to, I'm taking the square of this side. And when that happens, it is going to be the same as taking the square of 24 minus 3x all over 6, multiplying itself, multiplying 24 minus 3x all over 6. That's what it is. So let's do it. X now will come to be equal to, let us first of all work on the numerator. If we multiply all the terms in the numerator, it is the same thing as 24 minus 3x all squared. So what it implies is 24 squared for the numerator, 24 squared minus 2 multiplying 24 multiplying 3x plus 3x squared. Remember, your expansion is very important. And then for the denominator, 6 times 6 gives us 36. Alright, first thing first, we have successfully eliminated the root sign. If you take a good look at this stage that we have reached now, there is no square root sign, which means that we are heading somewhere. So what I'm going to do as I'm simplifying the numerator of the right hand side is to be multiplying or cross multiplying 36 and x. You can see this x on the left as x all over 1. So that 36 multiply x leaves you with 36x. And on the right hand side, we just need to open up the brackets. So let's do that. Our calculator can help us work. First, 24 squared gives us 576. 576, alright, minus 2 multiply 24 multiplies 3. That gives us 144. Remember the x. 144 with an x plus 3 squared is 9 and x squared is x squared. Alright, this is where we have reached so far. Now, what I'm going to do is to rearrange this equation. It has already appeared as a quadratic problem. So I'm going to rearrange and solve it quadratically. Therefore, still on my right hand side, 9x squared minus 144x. 36, I'm bringing it to the right, so that is going to make it minus 36x and then plus 576. Everything now is equal to 0. At this stage, we have reached the level where we can determine whether to use factorization method or any of the other methods of solving quadratic equation. Meanwhile, let's leave it as a trinomial first before moving further. So 9x squared minus 144 minus 36. What is it going to give us? This is going to give us 180. 180x plus 576 is equal to 0. It's time to solve. One thing I'm going to do first is to check if I can reduce this a little further, and I think I can do that. 9x squared divided by 9 gives me x squared alone. And then minus 18 divided by 9 gives me 2. So 180 divided by 9 is 20. Remember to bring down your x. Plus 576 divided by 9. Let's check it out. 576 divide this by 9. That gives you 64. Alright. So the equation has been reduced to x squared minus 20x plus 64 all equal to 0. Can we factorize this kind of problem? Let's think. 64 is the same thing as 16 multiplied by 4. And 20 is the same thing as 16 add 4. So it's going to work. In case you have not seen my video on how to factorize a quadratic expression or quadratic equation, it is important for you to see that at this stage, because I'm going to apply a strategy that I already taught in that video. Okay? Alright, so for those of you who are already following, the factors that we'll be working with will be negative 16x and negative 4x. So I'm going to be rewriting this equation as x squared minus 16x minus 4x plus 64 equal to 0. See, negative 16x minus 4x is the same thing as negative 20x. So nothing has actually changed. We just are bringing out the terms to work out the factorization problem. Now that we have reached this stage, x squared and negative 16x can be factored out together since they have a common factor of x. And that is what I will be working with. Pay attention as we create a little more space to work out the solution for this problem. Alright, so on the right hand side, I'm just going to rewrite what I have written down here, which is x squared minus, I'm writing it out here, x squared minus 16x minus 4x plus 64 minus 4x plus 64 equal to 0. Now let's factorize. These two will go together. I factor out x. When x multiplies x, that gives you x squared. So when x multiplies 16, that gives you 16x. The first part is factored. Now we want to look at factorizing negative 4x plus 64. The common factor we have here is negative 4. So I will be working with negative 4 because negative 4 multiplies x to give us negative 4x. Negative 4 multiplies negative 16 will give us positive 64. So everything is still equal to 0. Now at this level, notice that both brackets are the same. So it means we can factor out the bracket again. X minus 16 in one bracket going against x minus 4. Going against x minus 4. All is equal to 0. So splitting it now the way it's supposed to be in a quadratic equation situation, x minus 16 is equal to 0 or x minus 4 is equal to 0. What this implies is that x is equal to 16 or x is equal to 4. Therefore, and finally, the value of x is equal to 16 or 4. This is the answer for x in the first problem that we have just solved, which is 3 all over 2 3 all over 2 of x plus 3 root x is equal to 12. We have ended up solving this radical problem and we have found the answer for x as 16 or 4. Now, it is important to mention at this stage that even if the values of x have appeared to be 16 or 4, it is important for us to take the value that satisfies the equation that we have been given. If we test out the value x is equal to 16 in this equation, 3 all over 2 of x plus 3 root x is equal to, it is not going to give you 12. But if we test out the value 4, inside this equation, you notice that it's going to be 3 times 2 plus 3 times 2, which is 6 plus 6, 12. Hence, we end up our solution by saying that we are taking the value for x is equal to 4 as our only correct answer for this problem, because only 4 satisfies the solution set for the problem given to us, 3 all over 2 of x plus 3 root x is equal to 12. Only when you use the value 4 will you get that answer. Please take note of that. Most of the time, exam bodies use this to test out student skills to see if it's just all about being able to solve a problem or being able to tell exactly which of the solutions merits or satisfies the problem you are given. Okay, so for now, our correct answer for the value of x is 4. Even if x appeared to be 16 and 4, only 4 satisfies our solution. So 4 is the correct answer, not 4 and 16. Is that clear? That is not all. We have one more problem. The problem looks bigger this time. That is problem B, where we have a bigger square root with more radical situations contained in that equation. What would you do if you were to solve that problem? You can pause this video and have a goal first, and then come back to see if you found it out. Assuming you have already attempted, let's solve the problem together now. First, I'm rewriting the problem B. And the problem B is we want to solve the square root of 0.5, 0.5x plus 6, still inside the square root, is equal to 1 add a square root of 0.5x. This is what we want to solve. So what would you do? I am just going to apply the same manipulation I did on this side. The first thing first I'm going to do is to keep all the roots on one side, while the numbers or variables or terms without the root stay on a different side. As you see here, only the digit 1 has no square root next to it, so it will be the only number to stay. I'll keep it on the right, while on the left hand side I'll bring the roots. So coming down, I'm going to write 0.5x plus 6, 0.5x plus 6 in one square root, minus 0.5x in another square root. Everything is equal to 1. This is where we are now. So to go a little further, my focus now is to find a way to remove the square roots. And to do that, I am going to take the square of both sides. Take the square of this side and take the square of 1. When you do that, what it implies is that we are multiplying everything together. You can take the expansion technique, or remember that when you are simplifying x plus y all squared, or you can say x plus or minus y all squared, usually this is equal to x squared plus or minus 2 times x and y, which is 2xy, and then plus, since it's plus or minus, it's going to be plus or minus y squared. So in this case, our x is represented by 0.5x plus 6 in one square root, while our y is represented by the square root of 0.5x. So applying the technique of expanding a bracket involving squares, I am just going to apply what I've shown here in solving this problem. Okay, remember this. It is very important to help you right now. So let's do that. What it implies now is that the root of 0.5x, the root of 0.5x plus 6 together in the root, we're going to take the square of this part first. After that, since it's a minus, we're going to now minus 2 multiplies the first square root, which is 0.5x plus 6 in one square root, times the second square root, which is 0.5x alone in 1, and then for the final one is going to be plus 0.5x in 1 square root, 0.5 plus 0.5x in 1 square root all squared. This is what we are dealing with. But remember our 1. The square of 1 remains 1. So this is equal to 1. Okay? Don't get confused. We are still working with the 1. Now at this level, it's time to simplify. First, the square outside destroys the square root inside. So we have 0.5x plus 6 without a square root. Now, minus, take a look at this level here. Do you remember that in your sword, when you were dealing with sword, the sword of m, or the square root of m, multiplied by the square root of n is usually the same thing as the square root of m times n. You understand that? I am also going to use this technique to help me to simplify the case we have here. So y2 remains outside the bracket, or 2 multiplying square root, both terms that we have right here will be exactly inside 1 square root. So what it means is that I'll be multiplying 0.5x plus 6 by 0.5x. 0.5x, as you see here. This has been opened. Now plus, take a look here again. The square can cancel out the square root, leaving us with just 0.5x. All is equal to 1. At this stage, we are left just with 1 square root. Do you know what I'm going to do again? I am going to separate all the other terms to one side, while the square root term stays on one side all by itself. So to do that, first notice something. I'm going to collect like terms first. This is 0.5x, and here we also have 0.5x addition. I'm adding both of them together. Half add half is 1. So 0.5x add 0.5x gives me just 1. That is 1x. I'll write it down here. 1x first. Then what else do we have? We have just 6. So 1x plus 6. The 1 on my right hand side, I'm bringing it to the left now. So it's going to be 6 minus 1 is equal to whatever I have inside here, which is 2 root, or 2 multiplying the square root of. I'm going to open up the bracket. Let's see. 0.5x multiplies 0.5x is going to give us 0.25x, okay, with a square, 25x squared. And also add 0.5x multiplies 6 is the same thing as looking for the half of 6. So that gives us 3. But remember the x, 3x down here. This is still in a square root. We are progressing. Now what we have done so far is we are trying to simplify. At this level, I'm just going to simplify here and take the next step. X comes down, plus 6 minus 1 gives us 5. It's equal to 2 with the root of 0.25 with an x squared plus 3x. This is also in a square root. To make the root stay just by itself, I am going to divide each term on both sides of this equation by 2. And when I do that, the 2 on the numerator on the right hand side cancels out the 2 on the denominator of the right hand side. So that on the left, we just have x plus 5 divided by 2. And on the right, what we have is the square root of 0.25x squared plus 3x. But remember, it is inside a square root. Now at this level, my next focus will be to remove this square root sign. And to do that, I will need a square. So I have to take the square of both sides again. Now let's simplify. If I take the square of this side, it simply means x plus 5 squared divided by 2 squared. 2 squared is 4. It's equal to the square on the right cancels out the square root, leaving us with 0.25x squared plus 3x. This is where we have reached. Now I'm going to open up this bracket and see if I can collect like terms. So to open up the bracket, x squared leaves us with x squared plus 2 multiplies x multiplies 5 is going to give us 10x, and then plus 5 squared gives us 25. Everything is still all over 4 is equal to 0.25 25x squared plus 3x. We are progressing. Now, what can we do to move a little forward? Since we've reached this level, I just need to find a way to remove this fractional case. In that case, I will allow the right hand side to be all over 1 so that both of them appear fractional in nature. Now I am going to cross multiply. When you multiply x squared plus 10x plus 25 by 1, it remains the same. So on the left, I still have x squared plus 10x plus 25. I just multiplied it by 1, so it remains the same. But on the right hand side, something is going to change. Since I'm cross multiplying, 4 multiplies 0.25. 0.25 multiplied by 4 gives you 1. So you just have 1x squared, which is the same as x squared. Alright? Plus 4 multiplies 3x gives us 12x. Now notice, it is a pure quadratic case. But right now, we can also reduce it to linear. On the left hand side, we have x squared. And on the right hand side, we also have x squared. Both x squared can cancel out each other, leaving us with 10x plus 25 is equal to positive 12x. What can we do here? At this point, what we can do is, notice, this is 10x, this is 12x. I'm going to collect items, leaving 25 on the left hand side. So 25 stays on the left hand side as 25, while on the right hand side, I will be writing my 12x minus 10x. When this is done, I think we are very close. It's no longer quadratic, it has become a linear problem. And linear problems are the easiest kind of problems to solve. Alright, since we've reached this level, we are very, very close to our final answer. 25 on the left is brought here. 25 on the left is equal to 12x minus 10x leaves us with 2x. So, it is just a matter of looking for the value of x. To get the answer for the value of x, all we need to do is to divide both sides by the coefficient of x. And in the equation we have here, the coefficient of x is 2. So we'll be dividing the right hand side by 2 and dividing the left hand side by 2 as well. When this is done, 2 on the numerator cancels out 2 on the denominator, leaving x on the right hand side. While on the left hand side, we are still left with 25 all over 2. Therefore, we can proudly say that the value of x for this second problem we just solved is the same thing as 25 all over 2. You can leave it this way, or you can also write it in a mixed number form, which is going to be the same thing as 12 and a half, or 12 whole number 1 all over 2. You can also leave your answer as a decimal, especially since the problem started with a decimal form. So you can also write it as 12.5. Whichever way this is expressed, you are correct. What matters the most is that we have ended up finding the values of x in each of the problems that we have just solved, no matter how radical they appeared in the beginning. I want to believe that this problem will be helpful to someone who is trying to solve or learn how to solve questions of this nature. As always, thanks.